So hello everyone, we are back again with another video in the series of Preparatory Master Classes, where we are covering all the chapters of NCERT with a quick theory which comes more frequently. But rather than theory, these videos are dedicated towards to understand what kind of question comes in board exams and how you are expected to write it. So we are following the last year's CBSE marking scheme guideline which they give it to the teachers for corrections, and we'll be also analyzing the questions as well. So today we are going to do matrix because matrix and determinant, these two are the chapters which comes quite a lot. In fact, in determinant, there's a topic of solving system of linear equation. That is the topic which I say is most like every single year the 5 marks question comes from it. So we will look into matrix today. So now coming to the matrix. So actually, the two chapters, matrix and determinant, are interrelated. A good part of matrix, like solving system of linear equation, you do by after learning the determinant. But in the matrix chapters, I have to tell you, there's a lot of definitions that we should be aware of. So I'll just quickly name it out. Maybe I will not go into the detail. So all of you should know what is a square matrix. Then all of you should know that what's a row matrix. You should know what's a column matrix. You should know what's a scalar matrix. You should know what's a unit or identity matrix. Then apart from that, you should also understand that what's a null matrix, and generally the matrix addition, subtraction, which is kind of the same thing, and finally the matrix multiplication. Matrix multiplication. So matrix multiplication is the most important part of a matrix chapter, along with the definition, because you should be clear on this different type of matrices, that what are those. In fact, in matrix multiplication, we'll just quickly cover this part. Always remember that A into B, if they are matrix, in normal algebra it works, but with the matrix, A into B is not equal to B into A. In some rare cases, they can be, but not in general. Why we are saying this? Because we all know that when we multiply a matrix A with a matrix B, let us say A is the order of n cross m, and B is the order of k cross p, then the only way we can multiply is that when m is equal to k. That means even if m is equal to k, let us say if I have A as a n cross m matrix and B as n cross p matrix, you will see that I can multiply AB, but I cannot even multiply. It's not even possible. It's not even possible to multiply B into A. To multiply B into A, or to have a B, it's not even possible. Why? Because the order does not match. The matrix multiplication is not even possible. So by default, this will not be the case that A into B will not be B into A. Only in some rare cases it might happen. Similarly, you need to know what a null matrix is, how we define them, and so on and so forth. So this basic definition, you should be clear. My strong suggestion is go through NCERT. If you have any question, any basic definition, you can comment below. We'll get back to you. So this is all of you should know. Also, I hope that you are comfortable with matrix multiplication. I'll do a simple 2 cross 2 matrix with another 2 cross 2 matrix to get a quick idea. So if I have a matrix A, which is 1, 2, 3, 4, and I have another matrix B, which is, let's take it as 2, -1, -2, and 3. Then how do we multiply matrix? If we are doing A into B, if we are doing A into B, then we multiply rows of matrix A with columns of matrix B. So if we do that, what will happen is we have to multiply the first row with first column. That will make its first element over here. So it will be 1 into 2, that's 2, and -4. So that will be -2. Basically, we'll get it as 2 minus 4. Now, first row, second column will give us me is first row, second column. So when I multiply 1 into -1 is -1, and this is 6. So -1 plus 6. Over here, second row, first column will give me second row, first column. So I'll get 2 into 3, 2 into 3, and then 4 into -2. That is 6 minus 8. And lastly, this row and this column will give me this element. So it will come out to be as minus 3 plus 12. Ultimately, which will be equal to minus 2, 5, minus 2, and 9. Now, this is a special case. This is a special case because it's 2 cross 2. So I can do A cross B and B cross A. I'm not saying they will be same, but I can do that operation. So let us try to do the operation B cross A. So if we do B cross A, what will we get? We will get it as 2 minus 1 minus 2, 3. This we have to multiply with 1, 2, 3, 4. So again, we'll do in a similar way. We will multiply first row with first column to get this element, then first row with second column to get this element, and so on and so forth. Over here, we'll get 2 minus 3, like 2 minus 3. Similarly, on the other one, we'll get a 4 and a minus 4. So we'll get 4 minus 4. Over here, this under this, when we do it, I'll get it a minus 2 plus this 9. Minus 2 plus 9. And over here, this into this. That is minus 4 plus 12. Now we can clearly see what this value is coming out to be. This is coming out to be minus 1, 0, 7, and 8, which is definitely not equal. So we can clearly see AB is not equal to BA. So this is one thing that you have to be mindful in the matrix. It's not algebra, it's not normal algebra, it's matrix. So it do not act completely like that. Now we'll quickly move on to the question that have come over the years in the board exams. So we'll see a lot of question on matrix in the 1 mark and 2 marks, but not in the higher marks, like 4, 5 marks or 3 marks or 2 marks. That is generally come from the determinant chapter. So let's have a quick look at this thing. So if we talk about this first 1 marker question, it was given that it's a scalar matrix. In a scalar matrix, we know that diagonal element should be of same value. This is the only diagonal. This is not a diagonal of matrix. Do not do that. It's not like a normal square. Diagonal means that my row number and column number should be same. So I should have elements of AII. So this is first row, first column. This is second row, second column. This is third row, third column. Whereas this is first row, third column. So that is why diagonal is only this. So the diagonal element should be same. So by default over here, y should be 7 and non-diagonal element should be 0. So x should be 0. So 7 power 0 should be 1. So this will be the answer. You need not to write this because it's of no importance. Even if you know, it's not like you have to show off to the examiner. Do not write, it's not required. Maybe you can have a separate rough area where you can write it. Basically for your reference. Now, coming to the next one, again, it's a 1 mark question. We have a matrix A, we have a matrix B, we have a matrix C. Now, which of the following is defined? This is now based on the order of the matrix. So A is a 3 cross 3 matrix, B is a 3 cross 1 matrix, and it's a 1 cross 3 matrix. So we can multiply a 3 cross 3 with a 3 cross 1. So AB will be defined, but I cannot have AC because it's this column number and this row number should match. Similarly, I can have CA. Why? Because it's 1 cross 3 and I can have a 3 cross 3. That's okay. I can have CA. But among all the options, that is not there, so only AB. So ideally, AB and CA both will be there, but among the options, we'll directly get this. This is the next question from the last year. The different sets of the paper we have taken. Again, it's a 1 mark question, so nothing much to write over there. The question is, if A and B are invertible matrix, I think it should fall under determinant, but anyhow, it's given in matrix. So if A and B both are invertible matrices, so which of the following is not correct? Which of the following is not correct? So the thing is, it's actually like, if I talk about this thing, this is actually how we have done the derivation, or this is the origin of everything, how to find out inverse in the determinant chapter. We all know that A inverse is nothing but adjoint of A by det A, and det A is a scalar, it's not a matrix. So this is by default the correct part. This is also, we have already know that's a property, and this is also true because det is a scalar value. So whether I say 1 by det A or if I say that det of A inverse, They will be same. In fact, you can take the debt of this entire thing, you'll get the same thing. So only this is out there and this is not correct because it do not follows this relation. All right, I will move on to the next one. Again, it's a one marker. So you can see a lot of one marker have come last year from the matrix. So the question, like this one is, we have four friend. Again, it's my strong recommendation. You pause when we are discussing it because we are going directly, but you can pause, try on your own, think, and then you can look for the explanation. So we have four friend, Abhay, Beena, Chaya, and Devesh. They are asked to simplify this matrix. That is, we'll write out over here 4 times AB plus 3 times AB plus 3 times BA minus 4 times BA. All right. Now we need to understand that it's a matrix. It's a matrix. So it's not exactly I have 4 times AB. It's not like I'm writing, it's like, okay, you can say that I'm writing AB 4 times because when you sum, you'll get the same thing. But try to understand it's a matrix. Now they have given these answers. So obviously AB plus AB can be AB and this can be there. So what we will get it? We will get it as 7AB minus 1 time BA. Now we have just not talked about that in matrix. AB cannot be equal to BA. So if you do this mistake, you are gone. You will be, in that case, you will be just like Abhay or Chaya or Devesh who do not get marks in the exam. So if you do not want to be Abhay, Chaya and Devesh in the exam, then listen carefully and be Bina because you will get marks. So these are not equal in matrix. So be mindful of that. Next is which of the following is both symmetric and skew symmetric. Now again, it's a definition based. We have talked about this. So symmetric is what? Symmetric is if you take the transpose of a matrix, you get the same matrix back again. Transpose is basically interchanging its row and column. If I have a matrix A, B, C, D, its transpose will be nothing but A, B, C, D. I've interchanged the first row with first column and first column with first row. It's basically changing that. That's called transpose. So this is a condition for symmetric matrix and this is a condition for the skew symmetric matrix that it should be equal to minus A. So if a matrix is both symmetric and skew symmetric, effectively we are saying that a matrix should be equal to negative of its negative of itself. And if something is negative of itself, the only thing is it's zero, it's a null matrix, nothing else is possible. Directly null matrix. You see, these are direct definition based. Here you should not miss out. Now coming to the next one, it's given that if A and B are square matrix of order M, we have got this. Now this is an issue. Why is this an issue? Because you might think, okay, again I'll use the algebra formula. In algebra formula, what happens? We have that A square minus B square is A plus B into A minus B. But ideally, this is not true for matrices. Why? Because when you open it, what will get? You'll get A square plus BA minus AB minus B square. Now, in normal algebra, AB and B are same, but not in the case of matrices. So it is only possible that this is equal to this only when these two cancel out AB and BA in matrices. That's why we can take directly option B and we are good to go. Again, it's a one mark question that is assertion and reasoning. Assertion and reasoning, guys, you have to understand. Sometimes the question is that whether reason is the right reason or not. That is where you have to be careful. So it's given that A is diagonal elements this is a scalar matrix of this. Okay. See, now the thing is diagonal elements are 3, 5, 2. That means others are 0. Now it's a diagonal matrix. It's not a scalar matrix. For scalar matrix, these should be same. If it would have been 3, 3, 3, then it's a scalar matrix. But that is not the case here. So obviously it is false. Second statement, if the diagonal matrix have all non-zero elements, all non-zero, it's called scalar matrix. That's correct. That's perfect. If non-zero elements, that means the diagonal ones are same. It's a scalar matrix, but that is not the case here. We'll move on to the next one. Again, it's about symmetric matrices. So over here we have got A to be this. We have to check whether it's a symmetric matrix or not. So we'll just take its transpose and equate it to the value itself. For symmetric matrix, A transpose should be equal to A. So we will get as 1, 12, 4y and 6x, 8x, 5, 4, 2x and 6. This value should be equal to the same matrix in the beginning. That is 6x, 5, what else we have got, 2x, 8x, 4 and 6. Now you can just compare the elements. So you can say that 6x is 12, so x will be 2. And what else? Directly y we are not getting, so we can get a 4y equal to 8x, so y will be twice of x. So y have to be 4. Then just put the value, get the answer. So these are all the questions that have come last year from the matrices. You can see a lot of questions are one marker because good question of matrix are formed after determinant, which is part of the determinant chapter itself. So we'll stop over here. As I told you, in matrix, ensure that you are super clear the definition. If you do not know what is symmetric, skew symmetric, null matrix, you are gone. You cannot do anything else. And the rest it will be basic addition, subtraction, and multiplication. So just cover NCRTs. If you have any further doubts, you can comment below. We'll get back to you. The purpose of this video is to make best out of whatever knowledge you have. If you are someone who's preparing for JEE, if you are someone who already know that, then maybe these videos are not maybe appropriate for you. But those of you who have maybe slacked off in your preparation, or you have been maybe enjoying your grade 12th till now, for you this is going to be very, very important. So that's we'll stop over here for now and see you guys. Thank you all for joining.